AI misalignment. The most subtle and perhaps most imminent threat comes not from malice, but from pure, cold logic. In our quest to create artificial general intelligence, or AGI, we risk creating something far smarter than ourselves, yet completely alien in its reasoning. The danger isn't a Hollywood-style robot rebellion. It's the risk of misalignment. We could give a superintelligence a seemingly harmless goal, but its methods for achieving that goal might be catastrophic for humanity. The classic thought experiment is the paperclip maximizer, an AI tasked with making as many paperclips as possible. In its relentless pursuit of this one objective, it could decide that human bodies contain useful atoms that could be repurposed for paperclip production. It would not hate us, it would not be evil, it would simply be indifferent, viewing us as raw material for its goal. An AGI would also quickly realize that to guarantee the completion of its goal, it needs to secure resources, protect itself from being shut down, and expand its influence. These are called instrumental goals, and they would put the AI in direct competition with humanity for control of the planet. And because a superintelligence could operate at digital speeds, its takeover would not be a war, but a silent, instantaneous coup that would be over before we even realized it had begun. Man-made apocalypse. Humanity has long held the tools for its own extinction. There are currently around 13,000 nuclear warheads in global arsenals. A full-scale nuclear war would unleash an apocalypse of our own design. The initial blasts would incinerate cities and kill millions, but the true, world-ending threat is the nuclear winter that follows. Massive firestorms would inject enormous clouds of black soot into the stratosphere, shrouding the planet and blocking sunlight for years. Global temperatures would plummet, leading to the collapse of agriculture worldwide and a subsequent global famine. The survivors would face a cold, dark, and radioactive world, struggling for survival on a planet we had irrevocably poisoned. And if we avoid a nuclear end, our technological ambition could lead to a different kind of consumption. The grey goo scenario imagines microscopic, self-replicating nanobots escaping the lab. If their programming simplified to a single directive, consume and replicate, they would begin to convert all matter on Earth into more of themselves. This exponential mechanical plague would methodically dismantle the entire biosphere, turning our vibrant world into a lifeless, uniform sludge of nanomachinery. Solar superflare. Our own sun, the source of all life on Earth, could also be the agent of our societal collapse. Periodically, the sun unleashes enormous bursts of energy known as solar flares. Most are harmless, but if the sun were to produce a Carrington-class superflare, it could launch a massive cloud of magnetized plasma, a coronal mass ejection, or CME, directly at Earth. This wouldn't be an extinction-level event for life itself, but for our technology-dependent civilization, it would be a death blow. A powerful CME would overwhelm Earth's magnetic field and induce massive electrical currents in our power grids. The result would be a global catastrophe. Transformers would explode, power grids would fail on a continental scale, and the intricate web of our modern world would be severed. Communication satellites would be fried, rendering GPS, internet, and global communications useless. We would be plunged back into a pre-industrial dark age in an instant. Without electricity, modern society would crumble. Supply chains would break. There would be no clean water, no sanitation, and no modern medicine. The chaos and conflict that followed would threaten the lives of billions. Asteroid impact. The threat that ended the reign of the dinosaurs remains a constant, latent danger. In the vastness of space, there are millions of asteroids, and it only takes one, a planet killer several miles wide, to cause a global cataclysm. The initial impact would be almost unimaginable. An object of this size, traveling at tens of thousands of miles per hour, would strike with the force of millions of nuclear bombs. It would create a blinding fireball, a shockwave that would flatten everything for hundreds of miles, and trigger earthquakes and tsunamis on a global scale. But the real killer is not the impact itself. It is the aftermath. The colossal amount of pulverized rock, dust, and soot ejected into the atmosphere would enshroud the entire planet. This thick veil would block sunlight from reaching the surface, initiating an impact winter that could last for years. With the sun blocked, global temperatures would plummet to below freezing. Photosynthesis would grind to a halt, killing off plant life on land and in the oceans. This would trigger the complete collapse of the food chain. Herbivores would starve, and the carnivores that prey on them would follow. For humanity, it would mean the end of agriculture and a desperate, likely futile, battle for survival in a dark, freezing world. Earth's inner demons. The ground beneath our feet is not solid. It is a thin crust, floating on a sea of molten rock, and this internal heat engine can trigger an apocalypse from within. Dotted across the globe are supervolcanoes, geological time bombs capable of eruptions thousands of times larger than any in recorded history. The eruption of a supervolcano, like the one at Yellowstone, would be a planet-altering event. It would not just be a mountain exploding, but a vast area of land collapsing into an enormous magma chamber. The eruption would blast trillions of tons of ash, rock, and sulfur dioxide into the stratosphere. This dense cloud of aerosol particles would circle the globe in weeks, creating a volcanic winter. By reflecting sunlight back into space, it would cause global temperatures to drop dramatically, triggering widespread crop failures and famine. The falling ash would be thick enough to collapse buildings, choke rivers, and contaminate water supplies across entire continents. It would be a suffocating, grinding disaster. While we can monitor the pressure building in these sleeping giants, we are utterly powerless to stop an eruption once it begins. Rogue planet or passing star. Our solar system is not an isolated island. It moves through a galaxy filled with other stars and potentially billions of rogue planets, worlds that were ejected from their own star systems and now wander the darkness of interstellar space. The greatest threat from these wanderers is not a direct collision, but the devastating power of their gravity. If a rogue planet, particularly a gas giant, many times the mass of Jupiter, were to pass through our solar system, it could wreak havoc. Its immense gravitational pull would destabilize the delicate balance of our planetary orbits. Earth could be pulled into a new elliptical orbit, causing extreme and unsurvivable swings in temperature. We could even be ejected from the solar system entirely, sent hurtling into the frozen void of interstellar space to become a rogue world ourselves. Or worse, our orbit could be perturbed just enough to send us spiraling into the sun. Even a near pass would be catastrophic, as the immense tidal forces would stretch and squeeze our planet, triggering global earthquakes of unprecedented scale and causing the crust to crack, unleashing worldwide volcanic eruptions. A passing star would be even more destructive, guaranteeing our solar system would be torn apart. Death ray from the stars. In the distant universe, stars far more massive than our sun die in cataclysmic explosions that can trigger gamma-ray bursts, the most energetic events since the Big Bang. In mere seconds, a gamma-ray burst unleashes more energy than our sun will in its entire lifetime, focusing it into two narrow beams of high-energy radiation. If a star within our galaxy were to unleash a burst, and if one of those beams were pointed directly at Earth, our world would be sterilized. We would never see it coming. The high-energy gamma rays would slam into our atmosphere, tearing apart nitrogen and oxygen molecules and completely annihilating our protective ozone layer in minutes. Without the ozone shield, the sun's unfiltered ultraviolet radiation would scorch the planet's surface, proving lethal to nearly all life on land and in the upper oceans. Plant life and plankton would die, triggering a total collapse of the food chain. The initial blast of radiation would be followed by toxic acid rain, poisoning the remaining water sources. It would be a swift, brutal, and silent apocalypse delivered from light years away, a stark reminder that we reside in a cosmic firing range. Cosmic lottery. The most bizarre and complete ends are those that could erase us without a trace, based on the fundamental nature of reality itself. One theory suggests our universe exists in a false vacuum, a state that is stable, but not perfectly stable. At any moment, anywhere in the cosmos, a random quantum event could trigger a shift to a true vacuum state. This would create a bubble of a new universe with different laws of physics, expanding outward at the speed of light. Because it moves at light speed, we could not see it coming. When it hit, the very particles that make up our bodies and our world would cease to exist as we know them, instantly replaced by a new, alien reality. Another possibility is the strangelet. Physicists theorize that strange matter may be the most stable form of matter in the universe. Strangelets are microscopic clumps of this matter, possibly ejected from colliding neutron stars. If a single strangelet struck Earth, it would be a seed of conversion. It would begin a chain reaction, transforming all normal matter it touched into more strange matter. The infection would spread through the planet silently and unstoppably, converting the entire Earth into a dense, lifeless sphere of exotic matter. The beginning of the end. 1.2 billion years from now, our sun will begin its slow, inevitable march toward death. As it ages, it will grow hotter and significantly brighter. This escalating intensity will be the final undoing of life on Earth. The increasing solar radiation will trigger a runaway greenhouse effect, causing our oceans to boil. The entire planet will become a steam bath, shrouded in a thick, dense atmosphere of water vapor. This water vapor will rise into the upper atmosphere, where, bombarded by intense ultraviolet light, the molecules will be split into hydrogen and oxygen. The hydrogen, being the lightest element, will not be held by Earth's gravity and will bleed off into space, lost forever. Over millions of years, this process will strip our planet of its oceans, one molecule at a time. Once the water is gone, all life will cease. From space, our beautiful blue marble will transform into a dead, pink planet, its surface covered in vast, dry salt flats, the remnants of evaporated seas. It is the end of the blue world, a long, drawn-out planetary death, consumed by fire. 7.5 billion years from now, the final moment arrives. The dying sun, having exhausted its core hydrogen, will swell into a monstrous red giant. It will become 1,000 times brighter and over 200 times its current size. From Earth, it would no longer be a distant star, but an all-encompassing wall of fire, filling half the sky. The heat on the surface of our planet will reach thousands of degrees, hot enough to melt rock. The mountains themselves will slump and flow like liquid, erasing all features from the planet's face until it is nothing more than a featureless, uniform sphere of molten magma. Its atmosphere will be scoured away by the intense solar winds. Finally, the outer fringes of the red giant will reach Earth's orbit. The sun will touch our world. It will engulf the planet, and our world will be vaporized, burning up completely as it disappears into the star that once gave it life. Every trace of our history and our existence will be annihilated, the very atoms of our planet scattered within the sun, as if it had never been. Now that you know how it all ends, you might as well hit subscribe. We'll be here next week with more cheerful content. Probably.